Hi, in this video we are going to work on arithmetic sequences. A sequence is a group of numbers following a rule. So a sequence can increase like 1, 3, 5, 7 or 2, 4, 8, 16, right? This goes further. Or it can decrease 2, 0, -2, -4 and so on, or 27, 9, 3, 1 and so on. So these sequences follow a rule, and this one and this one are called as arithmetic sequences because the rule is the common difference. You can see that these arithmetic sequences have 2 in common. So you just add 2 or you take away 2. It can be any other number, of course, but from one term to the other, you just move on by adding or taking away the common difference. Whereas these sequences are called as geometric sequences, which we will see further in this chapter. And the rule for the geometric sequences is the common ratio. So you just multiply, say, by 2, so it's times 2, times 2, times 2, or you divide by a certain number to get the next term. If your sequence goes bigger and bigger with every term, it's called as an increasing sequence, whereas if it goes smaller and smaller by each term, then it is a decreasing sequence. Now, let's go with some details about arithmetic sequences. So we write the general term as u sub n, right? This is the nth term, that's what we call. And what happens is the sub number n starts from 1 and goes up to infinity. So these are positive integers we're talking about. And a is the first term, whereas d is the common difference. And we can describe the nth term by using the first term and the common difference, because the idea is when you write the sequence, you go like the first term, and then comes the first term plus the common difference, and then you just add to the second term another common difference, so it becomes a plus 2d, and then the next term will be a plus 3d, and so on, right? So for the nth term, it is going to be the first term plus n minus 1 times d, because you can see the first term doesn't have any common difference added to it, but the second term has it. So this is the second term, and there is one common difference added to it. This is the third term, and 2 common differences added to it, right? So it must be 1 less than n. So it's a plus n minus 1 times d. So this is the nth term formula. Now let's see some examples. So in this example we are given the nth term of the sequence, and the first question is write down the first 5 terms of the sequence. Well, all I have to do is to substitute for n starting from 1 to 5. So the first 5 terms will be 53, 51, 49, 47 and 45 respectively. Now let's look at part B. Similarly, I'm going to substitute 99 for n, right, and find the 99th term. So B is nothing but u99 equals 55 minus 2 times 99, which will be minus 143. So this is part B. And for part C, I'm going to write an inequality to find the first term that is negative. So I'm looking for 55 minus 2n to be less than 0. Now, this makes 55 less than 2n, or in other words, 2n greater than 55. If I divide both sides by 2, I'm going to get n greater than 27.5. This makes n to be 28. So if I substitute 28 for the nth term, so u28 will be 55 minus 2 times 28, and that's going to be 55 minus 56, which will be negative 1. So this is the first negative term. Another example. Find the nth term of each arithmetic sequence below. Now, when it comes to finding an expression for the nth term, there are two ways. Now, the first way is that you will find the first term and the common difference. So here the difference is 20 minus 6, which is 14. And then substitute them into the nth term formula, like it's going to be 6 plus n minus 1 times 14, right? And if you simplify after expansion, that's 14n minus 14, and you will have 14n minus 8. So this is the nth term. Now the second way starts with the idea that the sequence for n is like 1, 2, 3, 4, 5, and so on, right? And the common difference here is just 1, whereas the common difference here is just 14. So every increase in 1 for n corresponds to an increase of 14 in this sequence. So I'll start writing, instead of n, 14 times n. Now if I substitute 1 here, it will be 14 times 1, which is 14, right? But my starting term, the first term, is 6, so I should be taking away 8 to end up with 6. And then I can try, if I substitute 2, it's 28, minus 8, 20, so I end up with the second term here. So that's how it works. Generally, such questions do not require too much work shown, but this is how you use the general expression to end up with nth term, and this is just using reasoning to end up with the nth term. For the second question, notice that the common difference is actually negative 7. So you add negative 7, or basically you take away 7 to end up with the next term. So you have to take into consideration that minus sign while writing the nth term, which would be 101 as the first term plus n minus 1 times negative 7, right? Then you will expand the brackets as minus 7 and plus 7, and the simplest form of this will be minus 7n plus 107. So this is the nth term for this sequence. One last example. The third term of an arithmetic sequence is 5 and the eighth term is 20. So the question is, find an expression for the nth term. We can write the third term as u3 equals a plus 3 minus 1 times d, right? Now we don't know the first term a, we don't know the common difference d, right? We're trying to find. So this is going to be a plus 2d, which is equal to 5. Whereas for the eighth term, it is a plus 8 minus 1 times d, which is a plus 7d, and this is equal to 20. Now this is nothing but solving simultaneous equations. If I multiply the first one by minus 1 and rewrite the equations, I'm going to have a simplified, right? It's going to be, these are cancelled, and 7d minus 2d will be 5d, which is 15. So from here I can end up with d being 3. And if d is 3, I can just substitute that value into one of the equations and find what a is, which is -1 in this case. Now is the time to write the nth term. So nth term will be un equals a plus n minus 1 times d. So if I substitute the values for a and d, then I'll have the simplified expression of, well, let me quickly write this down. It's going to be 3n minus 4. So this is the simplest form for the nth term. So as far as the arithmetic sequences are concerned, there's nothing much to work on. You have to know that a is the first term, d is the common difference, and the nth term is written as a formula here like this. And then you can just solve simultaneous equations, the hardest, to just find the nth term or whatever is asked. So the arithmetic sequences can be summarized like this. Thanks for watching.